We live in a world overflowing with data, making it incredibly easy to feel like you are falling behind. This sense of being overwhelmed marks the natural edge of your current understanding rather than a personal failure. Our standard way of processing information often fails because we fixate on chaotic end results, massive datasets and finalized decisions, while overlooking the small, quiet choices that initiated the sequence. Gaining clarity requires one deliberate action: slowing down. Before rushing to an answer, we must observe the immediate reality without forcing an instant conclusion. True understanding builds on foundations of careful, unbiased observation. It requires resisting the impulse for immediate answers to ensure the groundwork is solid. Consider a shopkeeper who notices a specific pattern. Whenever it rains in the early evening, her tea sales surge. Assuming the rain directly causes those sales is a risk. A disciplined observer looks for other variables, like a local festival changing the crowd, or the rain delaying buses, leaving commuters stranded right outside the door. This cognitive process involves separating the signal, the true underlying cause, from the noise, which includes all the distracting and irrelevant variables. Isolating that true cause transforms passive observation into actionable meaning. Identifying repetition allows us to uncover a pattern. When a specific behavior or event recurs under similar conditions, it reveals a structure we can work with. Mathematics provides the practical language to count these occurrences, compare outcomes, and measure our uncertainty about what happens next. Artificial intelligence lacks a mind or consciousness. It functions by scaling this mathematical loop of observation and pattern matching to a massive degree. Machines process information through three layers. First, reality, a chaotic space of shifting variables. Next, the data layer, a selective record of what sensors capture, leaving behind unmeasured context. Finally, the model layer compresses that data into a rigid structure for predictions. Every AI model functions merely as a compressed representation, carefully built to serve a very specific, limited purpose. This architecture has a fundamental limit. Pattern recognition differs significantly from actual intelligence. A system can easily learn the wrong lesson. For example, a model trained to identify animals might focus on the background lighting of photos rather than the shapes of the creatures themselves. Machine learning models blindly optimize for exactly what they are asked to see. They remain entirely unaware of the human context that wasn't recorded in the data. Human intent remains the essential requirement to test these systems and decide if an identified pattern is actually useful or dangerously misleading. A prediction is a mathematical guess about what might happen. A decision, however, is a physical action taken under constraints that carries real-world consequences. Executing a decision injects the model's logic back into reality. Complex systems, like city traffic or human markets, react to those interventions in ways a model cannot perfectly forecast. To navigate this unpredictability, we use feedback, a return path that allows us to correct errors after an action is taken. Humans experience this as learning, while in artificial intelligence, it is called backpropagation. The system sends error signals backward through its network to adjust its initial assumptions. Intelligence becomes a liability without a closed loop that continuously updates itself based on real-world consequences. Computation has firm limits. While machines process massive amounts of data traces, they cannot comprehend abstract human experiences like fairness, morality, or loneliness. The human must remain the final override, responsible for exposing hidden biases and possessing the courage to halt automated decisions when necessary. Psychology, mathematics, and computer science share a single universal discipline: understand before assuming, question before acting, and learn from reality. True intelligence emerges from an unwavering commitment to the continuous loop of observation and feedback.